Welcome back, students. Today we're going to do Module 3, Topic 9, Proving Lines Parallel. The standard for this topic is GR 1.1. I'm going to prove relationships and theorems about lines and angles, solve mathematical and real-world problems involving postulates, relationships, and theorems of lines and angles. The objective for this topic is you guys are going to identify and use parallel lines by using angle relationships. And the essential question for this topic is, why is it important to know how to prove that lines are parallel using angles? So we're on page 6 of the week 7 packet. Bell ringer is what we've got next. Please pause the video here, work the bell ringer, and then unpause. See how you did. I'm going to wait about 3 seconds. All right, find the slope of the line that goes through the given points. So slope is m, and to find our slope, it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And since we just have 2 points, we're just going to take the first point and make it x1, y1. The second point's x2, y2. I'm going to do this for all of them real quick. x2, y2, x1, y1, x2, y2. All right, so I just label them like that, and we're gonna plug in our points here. So I'll do number 1, start number 1 right here. M equals, so y sub 2 is negative 5. Y sub 1 is, we're going to say minus 3. All right, for our x's, it's 2 minus 0. So negative 5, negative 3 make negative 8. 2 minus 0 is 2. So number 1, this is negative 8 over 2. It's going to reduce down to negative 4 over 1. So that is our slope for the first one there. We'll go number 2 over here. So number 2, m equals, so our y's are 2 minus 2 on top. And then on bottom, we got negative 4 minus 1. So 2 minus 2 is 0. Negative 4 minus 1 is negative 5. Number 3, we'll do over here. M equals, so our y's are negative 3 minus 1. So negative 3 minus negative 1 on top. And then our x's are negative 4 minus 6. So this minus minus here, it's like negative 2 plus 1. I'm sorry, negative 3 plus 1, that makes negative 2. Then on bottom, negative 4 minus 6, that is negative 10. That's 2/10. That also reduces down to negative 1/5. Okay, so there's our slopes for 1, 2, and 3. Number 4 and 5 are describe the slopes of lines with the following relationships. Parallel. You guys remember, parallel lines are the same distance apart, and they never touch. And the slopes are equal for parallel lines. For perpendicular, a line that intersects another line and makes a 90-degree angle. And the slopes for perpendicular lines, as we learned in the previous lesson, slopes whose products equal negative 1. So when we multiply the slope of one line by the slope of the other line, it's going to equal negative 1. All right, let's go down to our guided notes. Still on page 6. Some colors together for you. All right, so theorem 3.19 is the converse of corresponding angles theorem. So, we learned before in previous lessons about the if-then and then the converse. If then is P, if P then Q. The converse is if Q then P. So before we were talking about, I think we were talking about the lines making the angle. We proved the angles from the lines. Today we're going to prove the lines from the angles. Some of this gets a little confusing. But theorem 3.19, converse of corresponding angles theorem. If 2 lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So this is kind of the other side of where we were talking about the lines. And it really didn't say in that lesson. I'm glad we're talking about it again here, although we've practiced it. So these two lines, this is your transversal right here, okay? So in this case, you just use the same colors. So 1 and 3 would be congruent. 2 and 4. 5 and 7. And we don't go past 3 when we're showing angles congruent. So I'm just going to circle the other. So 6 and 8. 6 and 8. So again, these, top right, top left, top left, top right, bottom left, bottom left, bottom right. All those corresponding angles are congruent. Just gonna say your greens. What did we do? Your greens, your reds, your pink, and then lastly, I circled 6 and 8. So how we can tell our difference there. So if these angles are congruent, these lines are parallel. Notice we have, the typical arrows at the top and the bottom. But we also have another arrow right here on both of these. And this means that they're parallel. When we see this in a drawing, that's our given that these two are parallel. So that makes all these things, all these angles congruent, or makes all those relationships happen. Okay, theorem 3.20, alternate exterior angles converse. So again, the converse of the alternate exterior angle. So remember that the interior would be in between the two parallel lines. Exterior is outside the two parallel lines. Again, we've got that extra arrow, meaning these two are congruent. These two are parallel, excuse me. Let's see. And so we got 1 and 5. So 1, I'm just going to make it green, and 5. So notice both of these angles are on the outside of the parallel lines. The 1's at the top, the 5's at the bottom, so they're alternate. So alternate exterior converse says if these two angles are congruent, these two lines are parallel. Or if these two lines are parallel, those two angles are congruent. Move up a little here. Okay. Theorem 3.22, alternate interior angles converse. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. So again, let's see, let's try. Give me just a moment. Little low on colors here. Okay, let's just do this. We'll do red in the middle. All right, so we're on the interior, and then it says alternate. And this is 7 and 3 that they're talking about. It's crazy. We'll do brown. So 7 and 3. So 7 and 3. Notice they're inside, and this is on the top, this is on the bottom. So alternate interior. If those angles are congruent, then those lines are parallel, or if these lines are parallel, those angles are congruent. All right, theorem 3.21, consecutive interior angles converse. So let's do it again. We'll do the inside. We're going to make it, this is more brown than red, but that's okay. So if two lines are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the lines are parallel. So supplementary, remember, equals to 180. And it's talking about 6 and 7. Let's just make them green. So we got 7 plus 6. So 7 and 6. I'm just circling them to highlight them. So notice they're interior and they're consecutive. They're next to each other. They're not across. But these two guys are going to be equal to 180. And if they are, those two lines are parallel. And vice versa. Okay, let's flip over page 7. Top of the page, we got an I do, A and B on the left, and a you do, A and B on the right. So number 1, page 7. Decide whether we have enough information to prove that line M is parallel to N. Notice the parallel sign. Those two lines next to each other like that means parallel. So it's red. M is parallel to N. So, page over. All right, so they give us that this angle and this angle are congruent. Okay? This being our transversal. So notice this is the bottom right, bottom right. Well, those are corresponding angles because they're in the same spot. Whether these 4 and these 4, it's the same. It's the bottom right. So they're corresponding angles, and decide whether they are parallel. And yes, they are parallel, and it's because those are corresponding angles. All right, B. So we have 2 lines in both directions. Okay, they tell us that these guys are congruent. Now, before we go further, look up here. This angle touches this line. This angle touches this line. That's why they're congruent, because we have something going on, some sort of measurement for both of these lines. Notice these, okay, this is touching S and M. This is touching S and M. Neither one of these angles are touching N or R. So they're not telling us anything about any lines except these 2. So little, spoiler alert, it's going to be no. There's not enough info. Now, what do we know about these two angles here? Well, these angles are created by these 2 lines intersecting, so these are vertical angles. They are congruent, so that's true, but it doesn't tell us if any of this other stuff is parallel. So we don't have enough information. We just know that these are vertical angles and that there's not enough info. All right, number 2 is a you-do. I'm going to pause. I always say that. I'm going to pause the video. I'm going to pause and wait for you to pause the video. Try the problem and then unpause it. We'll work together. All right, number 2, decide whether there is enough information to prove that M is parallel to N. So we have that same symbol again. If so, state the theorem that you use. All right, so number 2, we start up here. We have these 2 are congruent. And notice again, these angles are created by these 2 lines intersecting. So that is true. They are congruent, and those are vertical angles. But notice they only touch M and R. We know nothing about N, so we do not have enough information. We have to have that angle gives us how far this one's going this way and this one's going that way. We need that for both lines, M and N, to be able to prove they're parallel. We don't know which direction, how far, if it's the same or not. So it's not enough information. Just try to notice that when we're talking about these things, what does it touch and what does it not touch? So we'll go down here to B. Make this a little darker. So we got this angle here and this angle here. So forget S for just a minute. Let's just say we have lines M and N, because this is touching R, which would be the transversal, and M, this one's touching R and N. These are exterior. They're not in between, but they're outside. Let's do this green. They're outside of M. They're outside of N. So these are alternate exterior. And if these 2 angles are congruent, then these 2 lines are parallel. This alternate exterior angles converse. And it's the converse because the angles prove the lines, not the other way around. Okay, let's scoot up here. Number 3, I do. We got an A, B, and a C. Number 4 is a you do. Let's do I do together, and then you can pause and work the you do and see how you do after that. Same thing for 5 and 6. 5 is a I do, 6 is a you do. All right, so number 3. Use the information to determine which lines, if any, are parallel. State the postulate and theorem that justifies your answer. So, what I like to do on these, it says 2 is congruent to 8. So I'm going to use green to start with. So I'm going to do 2 and 8. I'm not making the congruent symbol. I'm just highlighting them. I mean, I could do that, but I want to be able to see. So I see that 2 and 8 are inside A and B, and that looking at this, say this top, this is the bottom. So 2 is on the top, 8's on the bottom. So these are alternate interior angles. I'm going to start using the symbols. That's the symbol for angles. So these are alternate interior angles. And we're going to use the converse because the angles prove the lines. And it's so alternate interior converse. And then it proves A is parallel to B. Remember, these two lines mean that that's parallel. So A is congruent to B. So that's number 1. Number 2, 3 is congruent to 11. Different color. I'm just going to mark A green so you guys will know which ones are which. So 3 and 11. We got 3 and we got 11. Okay, so we're going to look at it. If we're looking at A and B, these both, well, you see, we can't really do A and B. We're going to have to do L and M because these only touch A, they didn't touch B. So 3 touches L, 11 touches M. So we're talking about L and M. These are both, let's see, we're doing L and M. Let's see, we're going to say, notice that 3 is the bottom right, 11 is the bottom right. So these are corresponding angles. And if those are corresponding angles, see, one touches M, one touches L, that's going to put L, I'm going to make it a cursive L, is congruent, I'm sorry, it's parallel to M. I don't like doing the cursive L because cursive L means other things later on, and I don't like to confuse you, but it's hard. If I put the L like that, it's just going to look weird. So L is parallel to M. All right, finally, just make B brown so we know what we did there. Now, C, 12 is congruent to 14. So we got 12, there's 12. 12's over here, and 14's over here. All right, so if you're looking at L and M again, these both touch M, they don't touch L, so we got to go this way. This one's touching A, this one's touching B. Well, they're not both on the inside, so it can't be an interior or an exterior. Let's see. Actually, no. We're talking A and B. These are both on the exterior. This is on the right, this is on the left, or this is on the top, this is on the bottom. So this is alternate exterior angles, and it's the converse because the angles prove the lines, and we're talking about A and B, so it would be A is parallel to B. All right, number 4, that's a you do. Pause here. I'm going to wait 3 seconds and continue. Try to work this, see how you do, and then we'll continue. All right, number 4. Excuse me. Use the given information to determine which lines, if any, are parallel. State the postulated theorem that justifies your answer. A is, I'll make A green again, and it's 1 and 15. So 1's up here, 15's way down here. All right, so we got 2 sets of lines again. So this touches N, this touches K, this touches L, this touches M. So we may have 2 here. Notice, so if we're looking at, I'm going to, let's see, hold on. So we're going to do the interior blue. Notice these are both, but yeah, we'll do the interior for those blue and the interior for these. So it's going to be alternate exterior, whether you're talking LM or you're talking NK. Okay? So alternate exterior angles. This is the converse again because the angles prove the lines. And this actually goes for N, K, and is this L and M? So L, M. Okay. A little bit of a trick question. All right, B. the color B. We'll go back to brown. 3 plus 10 equals 180. So angle 3, angle 10. So these are interior, because I made all the interior blue for both of these. I know that's a little confusing, but, and notice they touch, they're both inside N and K. So we're talking N, I'm going to put N, K here. Those are the two lines. They're inside. And these aren't across, so they're consecutive. So these are consecutive interior angles. Of course, it's converse because proven lines, not the angles with this. And it's N and K because touching both of those. Notice it touches L but not M, so we're not dealing with L and M there. All right, and lastly on number C here, or number 4, C, it's 3 and 5. So C, this is a purple, okay. 3 is brown, so I'm going to kind of do the outside of it. And 5 over here. And luckily I didn't do that here. These were, you had to add them to equal 180. They're supplementary for B. Now we're going here. So notice 3 and 5 are both interior because they're both in the blue. 3 is on the bottom, 5 is on the top. So those are alternate interior. So that's what we do first. We figure out what type of angles we're dealing with, and then we decide this is the converse. And so this is L and M. It touches both of those. Notice here it touches N, but it doesn't touch K. So L is parallel to M. Okay. Skip down to number 5 and 6. Last of this page, 5 is the I do. All right, so find the value of X so that E is parallel to F. Identify the postulate or theorem you used. So first thing we're going to do, we have a little box here. Hope you guys are very familiar now with the box. That means we're 90 degrees. So then we got 4y plus 10. So we're dealing with E and F. They're not both on the interior. This is bottom left. This is bottom right. Yeah, as a matter of fact, I don't know that I have the theorem. But I know that this would be congruent to this. And the corresponding angle of this, these two are going to equal 180. So we're going to say 180 equals 4y plus 10 plus 90. So 90 and 10 make 100. 4y. Excuse me. All right, so now we're going to subtract the 100 from both sides to get y by itself. 4y is equal to 80. Divide both sides by 4. It's going to make y equal to 20. Now that looks like a 4, but it's a y. Trust me. All right, number 6 is a you do. Please pause the video here, work this problem, and then see how you do. I'm going to wait 3 seconds. All right, number 6, find the value of X. So that M is parallel to N. Identify the postulate or theorem that you used. All right, so we have these two equations. So notice that this one is with the top right. This one's also with the top right. So these are corresponding angles. We're going to put them equal to each other. So 6x minus 3 is equal to 2x plus 1. So subtract the 2x from both sides. 6 minus 2 is 4x minus 3 equals 1. Add 3, both sides. 4x equals 4. X is going to equal 1. And it's the corresponding angles. Oh yeah, to prove the converse, because we're trying to prove the lines with the angles. All right, let's flip over to page 8. Yeah, page 8, got this at the top. They're both, it should be an I do and a you do. Now these, we haven't really talked about quadrilateral, so I'm going to do them both. Independent practice begins at the bottom of this page. rest of page 8 and page 9. But number 7, so don't let this weird shape fool you, okay, or scare you. It looks like a big W, and it is, but for us, so this line is parallel to this line, and this line is parallel to this line. This creates a relationship here. Basically, excuse me, the 5x and the 2y, these are basically the same angle. This and this are going to equal 180 because they're consecutive interior. Notice they're inside these two lines and they're across from each other. So 5x plus 14x minus 10 is going to equal 180. Page, hang on one second. Yeah. So I'm going to add 14x and 5x. That's 19x minus 10 equal to 180. Add the 10. So, also notice it says solve for x and y. We have to get x, then y. Never in this class will we try to solve two variables at one time. We can't do it in geometry. So anytime you see solve for x, solve for y, put x's together and put y's together because that's the way the book's going to do it. You just had to know that these two equal 180, and that's something we'll get with practice. So, add 10 both sides, we got 190 equals 19x. Divide both sides by 19, you're going to get x is equal to 10. Now, so you could do this two ways. You know that this plus this are equal to 180, so we could plug in x here and then just subtract this number from 180, or put 2y equal to 5x, and we plug in x. So 5 times 10 is 50, so 2y is going to equal 50. Divide both sides by 2, and y is equal to 25. I believe I told you guys a different way to do this in class, because this is an after-the-fact video. So hopefully you listen and get this is a little easier than what I said in class. All right, number 8. So again, we can't solve for x and y, the same thing. We know that if these two lines are parallel, and they are because they show us these are interior. So these guys are alternate interior, so these guys are congruent. So we're going to put a congruent mark here and a congruent mark here. We're going to put them equal to each other to solve for x, and then this plus this equals 180. These two are supplementary because they're consecutive interior. So we're going to plug that in to use this to find what this angle is, subtract it from 180, and that's what y plus 6 will be. So first off, now that I've thoroughly confused everybody with it, 3x equals 2x plus 12 because they are congruent. We subtract 2x from both sides. 3 minus 2x is x. X is going to equal 12. Okay? So we're going to plug in that here. So 2 times x plus 12. That's 24 plus 12 is 36. So if this guy is 36 degrees, and of course 12 times 3 is 36, this is y minus 6. I'm sorry, y plus 6 is going to be equal to 180 minus 36, minus what we found for this guy because they're supplementary. So 180 minus 36, that's going to give us 144. So y plus 6 equal to 144 minus the 6 here. Y is going to equal... Hang on, I did this wrong. But hold on, let's see. See how I messed up. 84. Hold on. No, I messed up in class. I put the 4A. Okay, all right, hold on. Let's back this up. Back it up. Sorry. Okay. What did I do in class? 4x? Put these two equal to 180. So let's just go back and do it that way. So we're going to say 4x plus 2x minus 12. I still screwed it up in class. I put plus 12. No, it is plus 12. That is a plus. Sorry, I can't tell here. All right, 4 plus 2 is 6x plus 12 equals 180. Subtract the 12. 6x equals 168. Divide both sides by 6, and x is equal to 28. I don't know what I did the first time. I apologize. God, sorry. So we took 4x plus this guy. These two equal 180. So this plus this is 180. Just like this plus this equal 180. So 4x plus 2x plus 12. We solved for x, got 28. Over here, sorry. So this angle here, 3x. So 3 times 28 equals 84. Then you get y plus 6 equals 180 minus 84. This is 96. Then if we subtract the 6 from both sides, y equals 90. Sorry, if I thoroughly confused you, just see me in class. I apologize. All right, so that's the end of topic 9. If you have any questions, let me know. Until next time, have a good night.